Okay, so here we've got a description of solid potassium hydroxide, and they are trying to make the sample using the following method. Suggest ways to improve the method to obtain a more accurate mass of pure potassium hydroxide. So first thing that I would suggest is they've dissolved the sample in water. What I would say do is if you used deionized water, that means it doesn't contain any ions, and that way you improve your purity, if you want to talk about purity of this. Okay. Next one is they talk about using a measuring cylinder to measure the potassium hydroxide. A better way to do that is use a pipette. That's more accurate to measure the volume of the potassium hydroxide. And the final thing, they've actually only done this experiment once. I would suggest that you repeat the experiment to get results that are concordant. And if you remember what that means results that are close together. So 3 marks, 1 point for each one. Okay, the next one, the indicator was phenolphthalein. Which row shows the change in color? That would be seen. So phenolphthalein at the beginning, if we just check up here, at the beginning, it's going to be put into a alkali. So in alkalis, phenolphthalein is pink, and it's then going to become colorless as the solution becomes more acidic. Okay, next one. This is a calculation of a titration. So in order to do this, we're going to use one of my favorite triangles. So it's amount, concentration, and volume. And the way that I remember this is a chicken vindaloo. So let's put the numbers in that we know. So it tells me here that we've got 12.15 of sulfuric acid. So 12.15 centimeters cubed of this, and it has a concentration of 0.14, is reacted with 25 centimeters cubed of the potassium hydroxide, and it wants us to calculate the concentration. So let's put some question marks underneath there to remind we're going to find concentration. So the first thing to do is we start with the chemical that we know 2 things about, which is the sulfuric acid. And what I need to do first of all is work out the amount of the sulfuric acid that has actually reacted. So if I'm going to work out the amount of that is reacted, what I'm going to do using a triangle is do amount is concentration times the volume. Okay, so the concentration, so I'm going to put C times V. The concentration is 0.14, and we're going to times that by 12.15. But what we must do is divide that by 1,000, because the 12.15 is only centimeters cubed, and we've got to get into decimeters cubed. So if I just put that into my calculator, so 0.14 times by 12.15, and then we're going to divide that whole thing by 1,000. We have got 1.701 times 10 to the minus 3 moles of the sulfuric acid. Next thing to do is we have to link the sulfuric acid to the chemical it's reacting with. So to do that, we look at the ratio, the stoichiometry, and according to the equation, there is 1 lot of H2SO4 reacting with 2 lots of KOH. We've just worked out they've got 1.701 times by 10 to the minus 3. So what I'm trying to do here is go from here to here, and therefore I've got to go from here to here to here. Okay, so to do that, we are timesing by 2. So I've got to times this by 2. So let's times that by 2. I'm going to write the answer in red so we can see it's a new number in this part of the answer. And that's going to be times 10 to the minus 3. So we now know that we have got this many moles of potassium hydroxide, and we also know the volume of potassium hydroxide. So I'm going to use this now in the final step to calculate the concentration of the KOH. So KOH concentration is going to be amount divided by volume. So that's going to be A divided by V. A is the 3.402 times 10 to the minus 3. And we're going to divide that by the volume, which is 25. But again, what we must make sure we do is we take that 25 and divide it by 1000. So let's do that in this calculator. So divide it by 25, which we need to divide by 1000. And that's giving me an answer here of 0.136 moles per decimeter cubed. Mark wise, there's 4 marks in there, so you're definitely going to get a mark for the final answer. You're going to get a mark for this stage, and a mark for this stage, and then a mark for this stage to get your 4 marks. Okay, so in this part of the question, what we're going to do is we're told that this is the concentration in moles per decimeter cubed, and this is the pure material, but we started off with 2.56 grams of impure. So we need to work out how much of this material is pure and then compare it to this to get this percentage amount of potassium hydroxide. So to do this, first job is to convert this concentration in moles per decimeter cubed to grams per decimeter cubed. And to do that, we're going to use this triangle because what we're trying to find here is the mass. So let's just write that down so we remember. So the first step, we're trying to find the mass. In quantitative triangle, mass is mR times the moles. So the mR is 56, we're told that in the question, and the number of moles is the concentration. So let's put it into my calculator. So 56 times 0.175, and that's giving me an answer of 9.8 grams. So that 9.8 grams is in 1 decimeter cubed. But if you look at what they've done, they've actually only had initially 250. So the next job is to convert that into how much it would be in 250. To do this, we're going to use the chicken vindaloo, so amount, concentration, volume question here. Okay, and what we're trying to find in this example again is the amount, or how many grams we would have in 250 of the solution. So if we write down in step 2 that we're trying to find the amount, and the amount is the concentration times volume. So the concentration is now 9.8, and we're going to times it by the volume of 250 divided by 1000. So I've got 9.8 times 250, just putting that into my calculator, divided by 1000 is 2.45 grams. So this means that we've got 2.45 grams of pure potassium hydroxide in 250 centimeters cubed. They started off with 256 grams. So we can now complete the final step, which is the percentage mass. And all we have to do there is take the number we've just worked out and divide it by the mass at the beginning, and then times that by 100. So again, just plugging that into my calculator, timesing by 100, and that's given me 95.7. I'm just going to check. There's nothing here that says how many decimal places, so I'm going to give 95.7% as the final answer.